Hello, Natroners, and welcome back to another episode of VFX with Natron. So today's going to be a shorter episode because, as I mentioned in the previous episode, I'm in the process of moving, so things are going to change in a not so distant future. And yeah, anyway, I wanted to make sure that that I talked about what's going on and sort of wrapped up a few things. We're not going to be quite finished. Honestly, I'm not positive. Yeah, we're gonna try and finish a lot of things, but this is going to be a short episode. I want to keep going on the SeArray node. And then we're going to do some really fancy stuff. Next episode is also going to be a short one as well. Anyhow, let's get to today's goal. Today's goal, by the way, is not going to be 100% this. What we're going to be doing is I'm going to show you one of the potentials of what you're going to be able to do with today's episode. So today's episode, this is what you'll be, one of the things you're going to be able to do. All right, so as you can see, it's fancy, flashy light things, and it's really kind of cool, and something you probably haven't seen in other software or other using other techniques. You've probably seen it, but what you probably don't realize is that there's only one animation in that entire thing. It's only one simple animation, and we made that animation last time. In fact, we still have that animation because this is where we left off last time. We had this, and all we have is a couple, or we have one rectangle that's driving, or that's being animated in basically a circle. If we look at this, this is just an animation that goes of a box that goes around in a circle. We time loop it so that it can continue on indefinitely. And then we merge it. What we have to do is, because this is such a tiny thing, and the way that this array node has to work, it needs a source. Let me fit that. It needs the area, otherwise it will try to tile it. It tiles it based off of its source area. It works off of the ROD, and currently, because the ROD of our input is only this little bitty block right here, we need to put it into a bigger block to use as our ROD for the tiling, or for, it's not really, well, it's tiling, a type of tiling. So what we do is we're using this solid. Now, at some point, we're going to replace the solid, but right now we're only doing addition with this. We're not actually dealing with alpha channels and things like that, and that may have caused some issues with people. And we'll be dealing with that in the not so distant future. But I didn't want it to become too cumbersome. Anyway, so what we do is we merge it over as solid. The solid, then we tell it in this that we're using the bounding box of the solid, which basically changes our bounding box from this tiny little thing to the entire size of this, which means that it uses this entire thing as its source. So any animation that happens inside of this bounding box is also going to transfer. And this is an important point to remember, because it also means if you want to make the animation happen outside of the area, you also need to scale up the ROD so that it's bigger than your area. And we're going to probably run into that at some point in the near future. But then we run it through the array, and of course we get this, which is just, well, this right here, if I'm not mistaken. This is a loop. Yeah, this is 12 frame offset. Let's put it at about 13 frames in. Oh, stuff is off the screen. It's all over the place. So what we're seeing is animation. All right, this is because this is looping around, and these are just tiny little boxes. For right now, what we're going to do is we're going to copy the transform, and we're going to just remove the horizontal. What I want to do is I don't want the animation going on the x-axis for the moment. So what we're going to do is remove the animation here and reset this to its default. So all it's going to do is go up and down basically from now on. So we can see it's going to basically do this motion, and then we're going to just pipe that into the time loop. And we put that in there, and there we go. So now we can see we have this time loop, and as we go up at around frame 12, ish, we should see, let's see, we only have 3 rows with 1 column. All right, so the first thing we need to do is we need to get rid of this direction. This is, as you remember from the last episode, this caused a problem. I put this in. It was supposed to be this fancy feature where you could choose the direction that a tile. We haven't gotten to the point where that really mattered. And it broke the code. Unfortunately, turns out to be, it is broken in my source, unless you get to a certain level in it, and so I'm just decided it's not worth keeping it in. So what we're going to do is we're going to edit the expression first on this, and we're going to remove the parts that really make that happen. So for right now, we're just going to get rid of this second bit here, which is the else, and make sure we don't. I don't want to get rid of the stuff below it, but we want to get rid of basically line 23 and 24. So we're going to just delete that, and we'll keep going back till we get to 22. And then for here, we want to take from the beginning of the out here and remove this if statement, because we don't want that either. So there we go. That should result in giving us the same result where we just get our tiles. And I'm going to just adjust something here. I'm realizing I'm looking at the wrong thing. We're going to get rid of the tiles, and what that's going to do, let's make sure we set the properties down to 1 so that we can see this up here. So what we can see is that just gives us the output directly, and it's not going to, this tile direction isn't going to do anything from this point forward. So all we're going to do is we're going to get tiles, and they're going to go vertically when we change them in. You'll have to do it manually using other nodes. It can be done with other nodes. You just have to get creative. All right. So, right, so we're going to hit OK for right now. And what that means is we can scrub, and we can see that it, well, it's not going to show it right here because it's not refreshing. When I scrub through fast, it draws us at a lower resolution, and those don't draw out. But we can see that they move, they're offset by 12 frames, and we have 3 frames, or 3 of them. All right, so now that we have that, the other thing we had done is we had put this on top of the tile node to show what the tile node does. We don't really need the tile node anymore. Right, well, let's just get rid of the tile node. Because we don't want this refreshing while we're working on this, what I'm going to do is, this was where we had worked on from the last time. I'm going to eliminate that from this, and I'm going to copy this and where we're at, and we're going to just view that until we're done, or as we work on this. So for right now, we're going to keep working on SeExpr1 and the expression and getting it working and doing some things. So what are we going to do? The key thing right now is we don't have any extra inputs. We want to have, I want to have more inputs. In fact, for the sake of this, let's, oh yes, and we want to also disable, all right, yes, I said I was going to disable it. So what we're going to do is manage our user parameters first. And we're just going to go to the tile direction here. We're going to edit that, and we're going to just hide it, because we're not going to use it. We're going to keep it in there because we might add it back in, but for right now we're going to eliminate it so it's not a temptation and people go, oh, it's a broken control, it doesn't do anything. It is broken control. We know it's broken, but by removing, if we were to actually delete it, it could cause expression issues in the future if we want to re-enable it, and I don't want to deal with that. So we're just going to hide it. It doesn't hurt anything having it there. It's just going to be there in case we get back to adding it. All right, so the expression, what are we going to do here? We need first to try and do something where we're going to add something new. All right, to make sure that we can see this, I'm going to actually scale our output up to a much bigger size, so that our animation, our transform for this, for our animation is going to be bigger, and we can see this, them overlap better, and it, things are just better. All right. And what we're going to do is we're going to add in, I think what we're going to do is just simply add in a transform node. I want to add over here, I'm not going to have it connected to anything. I'm just going to hit T to add a transform node. And we're going to view that transform node. And what I'm going to do is you'll notice it's connected to it's at our, oh, actually it's at frame 5. We're going to go back to frame 1. And we're going to reset its center at that point. Why are we doing it here? Well, it's still small. Well, because I want our this transformation to happen with this down at its lowest point. And what we're going to just simply do is we're going to rotate this like 45 degrees. We're going to rotate it like this, and let's watch what happens. When we scrub, all that's going to do is it's going to make this animation go off to the side. All right, so we're going to have one animation that goes up and down, like so. This one goes up and down, and the second one is going to go diagonal, just so that we have two different inputs. They don't have to be fancy. It's just so we can see them. And then what we're going to do is take this and input it into the second. For right now, we're going to input it into the second input right here. And then we're going to layer this over it like so. Oops, oh, wait a minute. We want to, let me think about this. I think I had this just going into A, like so. And the reason for that, so right now, as we can see, we're going to scrub quickly, but we can see whenever we stop on a frame, it actually, the three nodes. In fact, you know what? For the time being, we're going to drop our rows down to 2 rows so that this will speed everything up. So what we're going to do is make it so that if the first input is going to be the one on the left, the second input is going to be the one on the right. And what we want to do is ultimately have it so that when these move, this one is going to go at a diagonal, whereas this one goes vertically. All right. It doesn't sound complex at this point, but understand that this is a repeating tile set. This is going to constantly repeat. So it's going to go 1, 2, 1, 2, 1, 2, no matter however many of these we make. And we can increase this and have as many, up to 10 total inputs. So how are we going to do this? Well, it's actually not as complex as you might think. Let's pull up our expression. Let's edit our expression. We are going to work on this live so that we can see this, the inputs together. What we're going to do is we're going to scroll down. We're actually going to make this larger, our text area larger, and we're going to go into our area where we actually go through our rows and columns. And what we're going to add in here is a simple, right after our columns input, we're going to hit return, and we're going to put tab in twice. And we're going to put an if statement in, and we're going to say if, and we created this variable up here called source, and the source is based off of it gets our first source frame. We can see that it says source is equal to 1, and then it says if source is less than or equal to source minimum, which is our source minimum is our first source input, which is here. Then make it equal to the source minimum. So it's by default 1, or whatever this first source happens to be, whatever we set it to. Right now it's 1 because we only have 2 inputs, 1 and 2. And then it says the source maximum will be whatever our last source is, which is currently 1. We'll be changing that in a minute. So, but we have to put in we have to test this and adjust this. So what we have to do is we need to say, if the source SRC plus the source SRC steps, and what steps is our source steps, and we assign that right here. We can see that it says that source steps. So this variable, we want to add the source and the source steps together. All right. And if they are greater than the source max, which is the maximum number, if it exceeds that, then we want to reset it so that it is it's not higher than the source maximum, because if it's higher than the source maximum, then it's out of the range. So then what we want to say is then we want to set the SRC equal to the SRC min. All right. So there we go. So that will say that as this increments, as this gets bigger, when it gets bigger than when these two together are bigger than the source, then it will be source minimum, or we'll reset it to 1. So it's going to go up, then it's going to go up, and it's going to go up and reset, basically. All right, so that's what the first line is going to do. Then we're going to hit return, and we're going to put in else, because now we're going to actually do the increment that increments it. Else SRC is equal to SRC plus step. Wait a minute, plus excuse me, SRC STEPS, steps. All right, so I think that's all we need to do. Right, that should work. All right, so this is going to now, if we hit OK, we should wind up, suddenly we should get, oh wait, it hasn't reset itself because all right. Oh, yes. And right now, if we rewind this and we hit play, we can see, all right, it didn't rewind. We hit play. We can see it didn't do anything. And you're saying to yourself, why didn't it do anything? Well, because we haven't actually increased our source, our inputs, so that we have more than one input. And there's a reason that this is important to set up. And by the way, when we change this, it did change. This should work. There we go. And you can see that all of a sudden, it's what the heck is going on? Why is that all messed up and screwed up and not looking right here? And very, very different than we expected. And we can see it doesn't look right. What's going on? All right. We have the exact same problem that we actually have with the first one, which is this, as we can see, the ROD for this is just this big. Well, if the ROD is this big, the problem is when it goes through our SeExpr, it's going outside the bounds of itself. So we start getting that white border around it when it goes outside of its initial ROD, which is the initial input. All right. So we have to, again, put this, or we have to run that through basically the same type of overlay. So we need to take this, we need to copy it. We need to put the solid here. And what I'm going to do, just because I want to ultimately change this, is I'm going to put a dot node here. And we're going to put that into the A. We've cloned this so that it has the same bounding box. And then we're going to put it into there. And then when we look at that, now the bounding box is, again, the same as our HD resolution. And when we put that through our SeExpr, we can see that should fix it. And now when we hit play, we should wind up with both of them animating to the resolution that we have. And that's all there really is to it. So now we've created an array that has these two things. And as we can see, one is offset from the other. And it's completely based off of what we feed into our SeExpr or SeArray node. This array node now can be however many of these two inputs as we want. And so that means, let's take a look at what this means. All right, so right now we only have two inputs, but if we set this to 3, watch what happens. We wind up with the first, we wind up with the second, and then we're back to the first, but offset in time. Then we go to we add another row and we wind up with the second one, again, going diagonally. Now, this is where the offset mattered, is when we go into columns. Because this is designed, the way this is set up, it's going to do columns first. So when we set columns to 2, we're going to see that now, oh, that's interesting. Oh, that must mean that the bottom of the array, I didn't really look at that close enough. We need to, let's go back to frame 1. Yes, this is off the bottom of the frame. All right, so we're actually hitting a problem with this, which is our ROD is bigger than or the ROD we need is actually smaller than the actual thing. And so what's happening is the edge, this is going off the edge. And so what's happening is it's repeating. So right here, what we're going to see is when any of these get to the edge, you can see that all it does is it continues that edge pixels, or those edge pixels, all the way down, and we wind up with these vertical stripes. That is a limitation, or it's not a limitation, it's an intentional implementation, because we need to control our ROD for the input of this node. It's an important thing to understand. So how do we fix this? In this case, we want that to exist. Well, all right. In order to make this work, we need to actually increase the ROD area of our solid node. So before we do this, I'm going to actually copy this because I want to keep an original one at our HD output resolution. But we're going to increase the size of this by just simply going to size and telling it, well, how much more do we need this to be? How much bigger does this need to be in any given direction? Well, it needs to be bigger. And also, by the way, this is going to affect our output. It is going to mean that a few of our array or of our nodes are no longer, our tiling is no longer going to happen between this width, unless, well, it could, but, well, all right, let's yeah, we can actually make it work. Let's see. Let's just add, I don't think we have more than 100 pixels, so we're going to hit, actually, we'll say 200 pixels. All right. So I've made this 200 pixels bigger than our HD resolution. I'm going to click center. And what that's going to do, it's going to give a buffer. And we can see now that our ROD, which is this outside box, is now big enough so that if we were to trace these down, we can see that it's bigger than the needed area. And so it's drawing bigger than our output resolution. Now our output resolution isn't drawing it, but it's actually going into our SeExpr node, or our SeArray node. And when we go back to our SeArray node and we look at it, we can see that we no longer have that problem because it is bigger than the area that we needed. So that's an important aspect of this. If your array objects go outside of it, it means that you need to compensate for it. It also means that if you start dividing it and you do it, for example, this way, in this situation, we have it going diagonally out. It also means when we subdivide it, it's also subdividing relative to this additional space here. So these aren't going to be perfectly, everything's centered relative to it, but it's going to be offset a bit. So, you know, it's just, you have to accept there's got to be some form of limitation, and that's just something you have to be aware of. All right, so how do we get it? We don't want this to ultimately transfer into our final output. We want to crop this for our final output, so we're going to run this. That's why we have this additional thing down here, and we just say, we're going to set this so that we're going to use the bounding box of B, and we set that here. And that will basically crop it. So there we go. This is what our final output is going to look like. Let's fit that to make sure. And we're going to rewind it and we're going to hit play. And also remember, by the way, in order to get this to draw properly, we do need to have it Natron render this at full all the pixels. This is an important aspect of this that it was enabled. It should have been enabled. If we turn it off, we can see that we get an error, but it was on by default. Anyway, it was on by default with the project. And when we hit play, this should render just fine, and we should wind up with our output. And, we can see, aha, we have a problem here. We can see that these are past the end of the loop. All right, so these are no longer animating. So what we need to do is we actually need to put another time loop in here. All right, so what I'm going to do is I'm going to bypass this time loop and put it, connect it to, and duplicate this here, because we want this to this to affect this branch. So in other words, both of these, this is just the same thing, but with the rotation in it. So we can see that this affects this branch, this affects this branch. So we need two independent time loops in addition to two transform nodes in order to get this transform node to time loop, or the output of that to time loop. We need it to be set up correctly. All right, so now when we hit play, everything hopefully will be, this might take a little bit, but it's worth noting. This is pretty much all we have to do. At this point, this is done. Now, all the big thing that we have to understand that we haven't dealt with at this point is the fact that these are being added together. We're only dealing with right now black and white. And we're actually dealing with black and white that keeps getting scaled past black and white. In fact, let's prove it right here. If we scroll our mouse over this, oh, it's actually not. This is not reporting properly here. This should, it's saying here, we can see the output. It's not actually showing our values correctly, which is a little, I found that odd that it's not reporting it correctly. Interesting. It's saying this is 0 when it's actually, this is actually this plus that, which means it's actually 2. It's 1 plus 1. All right, so we would have to clamp this, and to make this more evident, what we couldn't really do this prior to now because we didn't have multiple inputs. But what we can do here is we can color these now, each branch. And so we started off with this. We could color this at the original source node, but then every branch would be colored, and that doesn't help us. So what we want to do is color each branch. And so what I recommend doing is doing the color after our transform. It's just as simple as coloring it here. So how will we color it? Well, we can just simply put a color node in, or color correct node in, but make sure that our branch, it doesn't affect the branch coming off of it. So here on this branch, all we have to do is we can take and we'll branch the gain. And what we can do is just pull down, for example, here. Let's say we want to make this magenta. So we pull the green down to 0, and that will make it so that this branch is magenta. Then over here on this one, for this transform node, we can add a color correct node after it, and we'll set the color to color gain, and we'll set this one to yellow by just changing it like so. And now when we go into this, we should be able to see where the two overlap. We're going to see that they should form white. And so we can see that indeed we have the diagonals are all yellow, and and where the two overlap, we wind up with something that's white. And that is because we are adding the output of the SeExpr. That is what this T0 plus T1 plus T2. And right now, that is a limitation. That is something you just need to know. That's how it's working. And we're not going to be fixing that today. I just want people to be aware, because I'm sure this has bit some people in the butt who tried to throw in something more complex than a simple shape, or tried to add this together. We can fix this by clamping it. We could clamp, well, no, could we clamp it? No, we could just take, I'm trying to think of how we could, well, we could do the math. The only way to do it is to do the math inside of here, inside of a node. And at this point, I don't think, as much as this is cool, we're not at the point, and that's beyond the scope of today's episode. But this will, what this will work for at this point is glowing. And now you're saying to yourself, whoa, glowing, how can we do glow? Glow takes so long. It's such a severe calculation. Well, if we do the glow per frame, yes, it would be, it would take a lot of time. But what we can do, because of the way this works, remember, we don't have to do any of these calculations past this point. We're dealing with basically this, and this. In fact, we could even do this before that. We can do this before the transforms. We can, I'm just thinking about this. We could, well, no. Yeah, we can, let's keep it at this point. So we have this here. What we can do at this point is we can cache the animations at this point so that after the time loop doesn't have to think about anything, doesn't have to do more work than it needs to. So what we can do is put in some disk cache and frame ranges. So let's disk cache. Let's see. So we'll do a disk cache. We'll just do a disk cache. There we go. We'll do 2 of those. And we'll plop those in. And we're going to just tell it, we're going to manually set this. And we're going to set it so that it's frames 1 through 49. Because that's all we need. We're going to set it 1 through 49. And on this one, it's going to be manual 1 through 49. Oops, 1 through 49. And there we go. And then we can plug that in. All right. So what is that? That means that we can cache those things, and this will not have to do much more. But the other beauty of this is that means we can also glow these. So let's, instead of glowing this like this, let's set this so that this is a lot more interesting. Let's put a glow on here. Oops, I hit the wrong key. I hit grade. I wanted to hit tab, then hit type in glow, and let's do a glow. And we can see that the glow, all right, so the glow, what we're gonna do, oh boy, we need to do this after we've cropped to the image. So we're gonna disk cache it and frame loop it afterwards. So there we go. That way it will work from that point. And we're gonna have to do the same thing over here. Let's pull the disk cache out, connect, let's see. Oh, we want that there, excuse me. Let's see, we want the A to go there, then we want the B. We want it to go like that. And then we're gonna have that go like that. So, right, so there we go. So what that allows us to do is we can take this glow and we can copy it. Oops, why didn't that copy? Oh, it did copy. It's right there. We can put that at the disk cache. All right, so I don't want people to get too confused, but basically all we did is we rearranged it so that the solid that's setting up our bounding box is big enough so that our glow can occur inside of it. So we can look at each glow. And hopefully the area that, whoop, wait a minute, our glow, why is our glow not happening here? That's weird. Oh, I guess this is not bright enough, so we might have to drop this down a little bit to get the glow to take place. We'll just set it to 0 for right now. We'll set this to like 0. There we go. And it should, we're getting a glow. It's just not a very strong glow because it's magenta. Anyway, then it will disk cache it, and then it will time loop the disk cache. And then when we go back here, it doesn't have to calculate those glows. Again, all it's doing, if everything works right, is it's going to add the 2 on top of one another. And yes, it's not going to be perfect. We do want to, on this one, we do want to set this so that the green has a little bit of green. And over here on this one, the blue has a little bit of blue. All right, that way, hopefully these will add together better and we'll see it. And we'll see, it's not, is it perfect? No, it's not perfect. I'd recommend playing with this more, maybe bring this up to like 1.1. So it's a better yellow. And we could drop these down as well so that they're lower, so they get to white faster. And 0.7, 0.7. There we go. Well, anyway, this is the way that it works. Is you'd have to play with the making your glows glow in a different way. Oh, this isn't. This might not. Yeah, no. This should dull it down a bit. This should work. Just need to give it a minute to catch up with it. It's going to take it a minute. We just have too many things going on simultaneously. It's not so great, but whatever. We get the idea. The idea would be if you set your colors inside of this, you can wind up with a glow, and ultimately that is actually how I did the circles. As I just used radials instead of squares, and I had them doing loops instead of going at a diagonal, and then they added together, and then they went through the crop, and I cashed it out, and that's it. That's all that there is to this. So let's save this as a new project version so we can pick this up next time. And right, so today's goal was to basically give you what we've done here, which will result in, by using this exact same method, but adjusting your color correction basically and glow. It's actually I did a lot of the color correction with the radials. I did it on the glow node itself, but this glow node is cached. So the glow node, if you actually discache each of these, if you pre-cache it, this would. Oh, do I want to pre-cache this? Anyway, the key point here is it's not having to recalculate the glow for every one of these. It's only calculating one pink and one yellow, and then it's adding the two together when they get over each other. Is this perfect? It's good enough. It should work well enough for this from an addition standpoint. It's good enough, and it results in what we'll see in today's goal was this. That's exactly what's happening here. It's just the colors were a lot less intense. The glows were made a bit more intense, and that's just adjusting saturations and so forth. So anyway, thanks for watching, and keep on Natroning.